Test, test.
Ooh. Awesome. All right. So we've defined smooth scrolling. So what's next? So what I'd like to do is go ahead and take you through basically our path up through this point. There's some early investigation work that we did early this year. Early this year, we internally did an investigation where we set up some automated scrolling benchmarks running across 80 highly trafficked sites. We were looking to measure end-to-end latency and consistency of frame rate, starting from the time input arrived in the operating system until content was ready to actually scan out on the screen. Edge already had the instrumentation we needed to do, so that was fairly straightforward. And we dug into what Chromium had, ended up adding some additional instrumentation about presentation time. And then we ended up merging that with some information that's already available from Windows via event tracing, ETW, and post-processed the results to come up with some interesting numbers. So we ran these results on a Surface Go device. We did that as a proxy for what a relatively low-end laptop might look like, but it's a common user device. I want to clarify on some of these numbers. So the numbers here are about the numbers during the actual scroll interaction on a page. We ran this across multiple iterations, and the percentages are about the percentage of those 80 highly trafficked sites that actually demonstrated the behavior. So for example, for frames per second, we looked at means and mins. Chromium was averaging about 57 during touch interactions. For some sites, we were dropping as low as 45. For Edge, we were hitting about 50, almost 60, and we dropped, one site particularly dropped down to about 53. For Wheel, we did better. Chromium was up at 57, almost 58. Edge was maybe within rounding error of 60, pretty close. Next thing we did is we kind of looked at how many of these sites are consistently dropping underneath 50. We found about 10% of them were in Chromium. Edge actually stayed above 50. I think the lowest we hit was a 55-ish on average. Then we took a look at across the multiple iterations. In this particular case, we were running 6 iterations. Across the multiple iterations, how many times did we end up dropping frames? In Chromium, 95% of the sites dropped at least 1 frame during that. And we were hitting about 20% in Edge. So then we took a look at, on an individual iteration basis, how many consistently dropped at least 1 frame. On Chromium, 65% for touch, 30% for Wheel, and 5 and 0 for Edge. And then we looked at another thing, which is, so if you dropped a frame, how many frames, or how many times do you end up dropping multiple consecutive frames? And Chrome, similar percentages to the previous one, 60 and 30, and Edge was about 5. So really, when I look at this isn't about look at how good that was or whatever. This, to me, is really more about there's great potential here to improve this for the customer. And something that I'm super excited about being able to do is to try to bring that to Chromium as well. So then taking a look at what Chromium has today. So some of these, there's 3 metrics specifically that I wanted to go over. 2 of these are newer, I would say, and still work in progress, perhaps. One is there's a graphic smoothness throughput compositor thread metric. I should have clarified this all with an acknowledgement that I'm focusing on compositor-based scrolling right now, not mean thread-based scrolling. So the smoothness metric basically tries to track for a given interaction, if you want to generate a certain number of frames, what percentage of those frames did you successfully deliver? From our looks so far, this is a pretty good proxy for how well you did at delivering frames and hitting those vsyncs. Due to back pressure primarily, we'll slow down the pipeline if you're missing things. Another metric that is relatively new, and I don't have a whole lot to say other than acknowledging it's here and we're wanting to engage and help make this better. The graphics metrics team has added a compositor latency metric, which this metric basically tracks from the start of a frame until presentation time. How long does it take in various stages? So there's a measurement of the total latency, for example, from that start all the way to presentation. There's different metric for how long did the begin main frame take? How long did the compositor thread need to deal with that? How long did it take Viz and the GPU process to deal with the produced compositor frame? Then you can break that down into sub-steps as well. How long did paint take? How long did layout take, etc. I think this is a great metric for understanding the general throughput. I It's actually one of the first metrics that I think we've seen where it actually gives us insight into how Viz and the GPU process is really doing at delivering these frames. So I'm excited to see a continued improvement in this space. There's a little bit of a limitation here, though. If you end up with a total large latency, you don't really know why, because all you have is these individual measurements in isolation. And then I think probably the longest existing metric that people may be more familiar with is the event latency. There's scroll update, scroll begin for wheel and touch. And the one that gets the closest to end would be the time to scroll update swap begin for. This tracks time from when input arrives in the browser, at least on Windows in the browser, all the way to when you call swap start in the GPU process. It doesn't include the amount of time from swap start to the end, to when you actually present. And so there is still a lack of understanding with that one about if you actually hit vsync, but it's a pretty good measure of how quickly you're getting input through, at least. So these are some numbers that I pulled from our current channels. We haven't shipped stable yet, so you have to be aware of potential sample bias, I suppose. But I wanted to kind of talk through briefly. We use some fuzzy math on what this means from a user experience perspective. If you look at touch, for example, at P50, about 88% of the frames that we're trying to generate on the input thread, we actually succeed at generating. Then you look at some other data, and we know, for example, that the average touch interaction while scrolling is about 33 frames. So what that translates into, though, is you missed a few frames on an average interaction at the 50th percentile. Or if you put that in simpler terms, 1 out of 2 scrolls is potentially janky. So there's some work to do there. These metrics, like I said earlier, are still in development. There's some challenges. For example, I know from looking at numerous traces that you can get a wheel message that comes in late in a frame, tries to tick off an animation, but it actually starts at the next frame. And then this metric will actually report that you missed one of those frames because of that, even though practically speaking from the user's perspective, that 5 millisecond delay probably didn't even matter at all. So it's data. You can find whatever you want in data frequently, but I just wanted to acknowledge that. However, I think even taking that into consideration, you can't actually compensate for the overall amount of stuff that's missed. So when I look at this, well, we'll look at this one first real quick. So the event latency metrics, the way the Chromium pipeline works is, in general, scrolling input is intended to be dealt with in 2 vsyncs. Input comes in the first vsync, gets queued up and coalesced. The start of the second vsync, we start running it through the pipeline. Compositor thread is going to go and try to generate a compositor frame, submit it to Viz, and get it through the GPU before that vsync ends. What that means, though, is any time this number is greater than 2 vsyncs worth of time, so assuming 60 frames per second, you got about 35 milliseconds. Assuming that number is greater than that, that means that you missed at least the optimal delivery. Doesn't mean that it's not smooth if, say, everything is exactly delayed a frame, but it's not ideal. So you can look at the numbers here at P90. It's pretty clear we're already starting to drop below that ideal target. Wheel, actually, we're doing much better. If you take a look at the latency that Edge historically has had, it's within the margin of error, basically, in most cases for what Chromium currently has. So, and when I say wheel here, I'm talking about the actual wheel tick, not about the animation that plays afterwards. The animation, like you saw in the initial set of data, there's still some work to be done. And then just an interesting data point I wanted to mention. In Edge, we ended up getting our touch latency metric down to 15 milliseconds or less, but that was by leveraging OS components and stuff. All right, so I've kind of gone through and defined what is smooth scrolling. We've taken a look at some initial data, 2 different techniques of looking at this data. Now we can take a look at some of our trace analysis in terms of why did we miss on some of these things. So this one is something that we saw numerous times in traces. Anytime that you want to draw something in Chromium and update the screen, you basically tell Viz, hey, I need to know when the next vsync's fired. Please send me a begin frame when that's happening. And then the expectation is that that begin frame is going to arrive real close to this shade difference in grays here. However, at least sometimes 6.5 milliseconds would pass before that actually showed up. That's a pretty big outlier. but 1.5 wasn't that rare. And if you think about that from the perspective of getting frames through this pipeline on a consistent basis, 1.5 millisecond delay from here till it actually arrives is 10% of the time you have. So it's pretty substantial, and it can certainly cause you to miss things going out the back end of this pipeline. Another one that we saw quite regularly was compositor impl thread deadline misses. So normally, here's another example where you got a 1.6 millisecond delay when that vsync arrives. So in this case, it's a wheel animation, and right down here, we're basically trying to tick this animation, but the main thread is also interested in scroll offsets in this case. And so the compositor thread's going to go and notify, and I don't have it on here, but it goes and notifies the main thread that there's an animation update due to this scroll. And then the compositor thread, trying to be a good citizen and make sure that things look cohesive to the user. So for example, the content on the page is using the same scroll offsets as the user actually sees displayed, decides to give the main thread a little bit of time to come back with a frame. And so it computes this deadline based upon a 90th percentile rolling average, I think. And says, so let's wake up, and even if the main thread does not get back to me in time, I'm going to generate a frame at that point in time, and then we'll have time to get it out the end of the pipeline. But sometimes you don't. This is when that deadline fired, and this is when you passed off that work to the viz or GPU process, and then the vsync fired, and then the work finally was completed afterwards. So this is another example that we've seen quite a few times of misses. Here's another common cause we see. After you submit that work to the GPU process, you have to wait for the GPU to finish that work. But there's a single pipeline, we just call it GPU main. There's a single pipeline that all GPU work is running through. And sometimes that pipeline is just busy. So in this case, for example, there's tile rasterization work that was queued up before you ever got a compositor frame submitted. This tile rasterization work ended up taking 90 milliseconds. And the compositor frame that you were really trying to start here and finish by this point here actually doesn't even get to run until after vsync fired. So the other thing about this that we've noticed is sometimes you end up with compositor frames that are actually pretty fast to process when it gets to the GPU. But because you have outstanding work, you don't queue up the next frame either. And so occasionally that can cause what could have been a one-frame glitch to turn into a multi-frame glitch. And this is something else we saw from looking at traces. Sometimes shader compilation itself causes that GPU main work to take a long time. Just another example. And then mystery items. So I know you can't read this, so I'll try to kind of read through our understanding at least. And this is a great example of where we're learning still. It's a big complex engine and we acknowledge that, but we're learning. And so our best understanding of what happened in this case is that the compositor frame deadline that I mentioned a couple slides ago fired at this point in time. We tried to build a frame, but we're missing a tile to draw it. So we end up waiting on that. We get notified when that tile is ready, and then we try to basically queue up a draw. But then the main frame sneaks in a commit, and then you can't switch to that until it gets its tiles ready, which happens here. And then you would think that you would go ahead and draw, but it doesn't actually draw anything. So this, I don't actually know if this is a bug. Did we just misunderstand the trace? It's a great example, I think, of where we have a learning to do. And I would look to people that have more experience and expertise in this space to help make sure we're understanding this right. All right, so with all of that, I think the next question is, what can we do about this? So this is where I would again say, I look to the broader community. I know there's a lot of expertise and experience, and I'm sure that there's good ideas out there. I can go through a few that we've talked about. So the first thing I want to mention is thread priorities. While we were doing these trace investigations, one of the things that we saw quite consistently was that you would have a thread on that critical path of trying to get a compositor frame out the door, and those threads would get swapped out for something else, an iframe playing something or other. Basically, work is given equal priority to actually responding to user input as quickly as possible. So we ended up reaching out to the GPU team. talking to them about this. We actually found out that they were looking at something along the same lines, and Sunny actually went and did some work in this space. And if you were at the keynote yesterday, this was actually mentioned as lowering. We actually have this, I believe, at least being trialed on 78 right now. And it actually has lowered the latency for scrolling at the 99th percentile by 20%. That's the last number I heard. So that was good. Looks like we might have a win there on that one. Something that I would love to talk to somebody about is the scheduling. So the inflow frame deadline scheduling. Is there room to make some improvements here? Are there some known weaknesses in this space? What can we do? GPU main being a big bottleneck, I think, is an interesting problem. I've heard from conversations about the ideas of trying to offload some of the work on GPU main, perhaps passing that work off to the clients that are trying to queue it up instead. Is there changes we can make in the shader caching to help reduce the chance of having those long shader compilations? Those things can take tens, sometimes even in the low hundreds of milliseconds to complete. And then kind of a bigger idea, but would it make sense to actually have the compositor itself have its own GPU thread so that it's never really blocked behind content rasterization? This is something that we also talked to the GPU team about, and they actually did some prototyping with this in the last month. I don't know if they're ready to discuss results on it, but it shows at least some potential. And I can also say from past experiences working on Edge that this has been highly effective in the past for us. So I think it's an interesting thing to dig into if it would make sense in Chromium. Then this one is an interesting one. I've heard numerous times that there's some perf optimization, some real significant inefficiencies in that critical path. If people are aware of what these are and would be willing to share these, I would certainly love to be able to dig into those and see if we can find ways to help move that needle forward. And then another idea, this is more about reducing latency. Right now, Chromium's got that 2-frame pipeline. What if we started delivering input in the middle of that second frame and picking that input up just in time to generate a compositor frame at the end? Might be able to reduce that latency by half a frame, a full frame potentially. What if we actually delivered that input directly to the GPU process and had the ability to actually scroll for scenarios where the page is not concerned about the scroll offset, be able to scroll that even later in the pipeline, further reducing latency. So these are all ideas that we've talked about internally. We've started to talk about some of them with different teams. And I'm sure that people have other ideas in mind. So that's where I would look to you. So kind of next steps from here. I think that at Microsoft, at least, we're going to try to be doing a more rigorous analysis of what's causing the jank or the hitches in this pipeline. I know that there's also work going on with the graphics metrics team here to do the same thing. I'd love to be able to partner up with that effort and try to move this forward for everybody. Those of you in the community that have experience in this space and would be willing to engage in discussions about how to move this forward, that is something that we would certainly love to do. And then I'm hoping sometime over the next year that we should be able to prototype some of these ideas and see which ones seem like they have traction, move them forward. So with that, I wanted to say thank you. Appreciate your time. And if people want to have follow-up discussions on this, I'd be happy to try to see if we can try to find some time later today. That's all I got. Yeah, if there's questions, I'll do my best.
So I'm curious, you identified several. You identified several cases where we have some degenerate behavior that's causing increased latency. I'm curious what the relative frequencies of these events were, or if you can automate the collection of these events so that we can tell in aggregate, like how often are these different things happening?
So the ones that we mentioned, I would say, are ones that, so these were all manual trace analysis, but the ones that we mentioned, I would say, are the ones that we saw consistently enough to think that they're significant. Automating that is, when I said doing a more rigorous analysis, that's exactly what I'm referring to. I'd like to see a way to automate that trace analysis and really try to, I guess you could almost say, lay blame at some piece in the pipeline's feet. So.
One of the shortcomings we have in our existing metrics is that they're very graphic centric. They assume that if you don't need to produce a frame, then everything is fine. But one of the things that we've found is kind of a problem is when you input and frame generation is kind of like clockwork. And if those two ever get out of sync, your metrics can look okay, even though like scrolling looks pretty crappy. So we're trying to do something to capture that. We have an average lag metric that we've been working on. It's complete, but I think we still need to do some more verification work and make sure it actually works. But that's something else that we should be looking at. And I think today we just kind of, post input from the browser to the render and hope for the best. And quite often it doesn't quite work out like that. Like we send over input right on a vsync, and there's all sorts of cases where we end up on either one side or the other. So that's something else that we should be looking at. And I don't really necessarily have answers here, but we should talk about that.
So there's two things. One, the average lag metric, the last I saw it, doesn't actually track all the way through presentation time, which is unfortunate. This is an area that I think we can make some improvements. And then another thing with average lag that, unless this has changed like pretty recently, it doesn't include the slop between when you initially touch and start moving until that's recognized to be a pan. There's a delta that you've basically moved your finger until that turns into a pan. And the average lag metric also doesn't track that today. So it's a good example of how we definitely have room to make improvements in these metrics. Going back to the other one about input and output staying somewhat in sync and there being some edge cases, it actually reminded me of a trace that I looked at last week where I was scrolling on a site, and it looked pretty good, except the content was actually moving up, down, up, down, up, down, up, down. And taking a look at the trace, I didn't have enough time to actually root cause it fully, but it looked like it was some sort of fighting on scroll synchronization between the main thread and the compositor thread. So there's definitely just some, I would say, almost functionality bugs in this space that we can be looking into. I'd say that last trace that I showed, the mystery item one, that's another one where at least from the trace, it looks like there was at least 2 opportunities to actually get a compositor frame out the door. And in that case, we never did. And the user ended up waiting more than 60 milliseconds for an actual update. So you lost your smooth scroll. So, anything else?
I wonder if you've considered using a high-speed camera to validate some of these, just to see if the traces match up. I think you can even do this with your iPhone and 240 FPS.
Considered, yes. No, haven't gotten to it. So
I have experience doing this. So far, it's been with a particular test page where like you have an easily recognizable object on screen, and so in the camera frame, you can see both the source of input, the finger, and the drawn frame. I have a document about like the setup and bunch of results. So I'd be happy to help brainstorm some ideas around that if you're interested.
That'd be awesome. Something else that I know you can do on Windows at least is you can actually capture every individual frame that is being outputted. There's something called a slicer tool that lets us do that. We could take that and leverage the input, try to also quantify it that way.
Yeah, I will say that we have done a little bit of high-speed analysis in terms of evaluating prediction. So I don't know if Naveed or Ella are in the room, but they've been working on some of the prediction stuff specifically for scrolling, and we've been trying to evaluate the effectiveness of that. And it kind of also comes back to the average lag metric. And so we have an engineer that's been looking at, does the average lag metric actually capture the user's experience, or does it kind of smoothing out these glitches a little bit too much? So yeah, we should definitely talk.
Awesome. Anything else? All right. Thank you much. And again, if you would like to chat about this, I would love to engage. So thanks.